minutes.
Yeah.
And then there's a 30-minute question and answer with two of the students.
Yes. So I'll introduce the students in a minute. I'll do a little introduction, a short introduction before. So whenever you're ready to start, I can launch into that intro.
Yeah, ready, Tom.
Okay. Great. Sue, we're live streaming. Okay. We've got some background noise. I don't know what that is. Okay. Oh, hi. Is that your Sue? Maybe it's your background. Okay.
Better?
Yes, great. Okay. It's indeed a great honor and a pleasure to introduce Kai-Uwe Bergman, director at Bjarke Ingels Group, or BIG, as we know the practice, headquartered in Copenhagen and based here in New York. My name is Tom Verabas, professor of architecture in the School of Architecture and Design at New York Institute of Technology. The format for the Beyond the Envelope series of events is a presentation by the architect, followed by a student-led interview. I'm pleased to introduce here online Master of Architecture final year students, Amy Goldfisher, who's on Zoom, and next to me, also on Zoom, Angie Syed, who will jointly conduct the interview with Kai-Uwe Bergman after his presentation. Firstly, before introducing Kai-Uwe, I would like to warmly thank Dean Maria Perbolini for supporting this series of presentations and interviews titled Beyond the Envelope. Many thanks to Professor David Diamond, Director of the Master of Architecture program here at New York Tech, for supporting for third year this MArch graduate seminar course, also titled Beyond the Envelope, within which the series is set. The series could never be launched without the dedicated work of the Lectures and Events Committee, especially Committee Chair Athena Papadopoulou, Alessandra Mellis, and the invaluable administrative support of Susan Sternberg. Kai-Uwe Bergman is a partner at BIG, who brings his architectural expertise to proposals around the globe, including work in North America, Europe, Asia, and the Middle East. Kai-Uwe heads up BIG's business development, which currently has the office working in over 40 countries. He also oversees BIG's urban scale projects and supports BIG's landscape projects. Kai-Uwe's most recent contribution to the resiliency plan, Big U, to protect 10 miles of Manhattan's coastline, first envisaged through the Rebuild by Design competition to develop proactive responses to Superstorm Sandy. It is now being constructed with a completion date of 2026. Further projects include reimagining Brooklyn Bridge, Brooklyn Queens Park, Smithsonian Master Plan, Pittsburgh Master Plan, and Miami Beach Square. He complements his professional work through previous teaching assignments at Georgia Tech, Pratt Institute, University of Pennsylvania, IE University in Madrid, and his alma mater, the University of Virginia. Kai-Uwe had formerly been on the board of Van Allen Institute, and he participates in numerous competition juries and lectures globally on the works. First lecture at New York Tech, and it's great to have you back. The project in focus in this afternoon's presentation and interview is BIG's project for the Copenhagen Power Plant in Copenhagen, Denmark, completed in 2019. Kai-Uwe will present his view of public infrastructures for transport, industry, energy, waste, water, sewage, etc., as major investments in our public budgets, and how they always appear as gray areas on the city map. Like black holes in the urban fabric lost for the public realm, they are big, ugly boxes that cast shadows on the neighbors or block the views. What if we could harness those massive investments and imbue them with positive social side effects from the get-go rather than in retrospect? What if the massive volume of a waste-to-energy power plant could become a mountain with ski slopes in a city full of snow but without hills? By proactively crossbreeding public infrastructure with social programs, we can inject new life forms into the heart of our cities and leverage a city's infrastructural budgets to also fund their urban social philanthropy. Join me, please, to warmly welcome back to New York Tech, Kai-Uwe Bergman, partner at BIG.
Thank you so much, Tom. I think also I'd like to say a continuing relationship with NYIT. You are probably aware that my colleague Daniel Sundlin is also involved with NYIT and in many ways is enjoying having actually an entire studio embedded in our office. So if I were to able to take the camera and just bend it around the corner, you would actually see, I think it's 12 students from NYIT's urban campus downtown working out of our office. So it's been a really great way of engaging on a much deeper level. I think it's also fantastic that you have this kind of building envelope in-depth series, because I think so often projects are only glossed over. The sheer magnitude and complexity of a project and what all someone has to actually figure out is sometimes really hard to communicate in both magazines, online blogs, and sort of a survey lecture. So I really want to do a deep dive as requested. And I also look forward to the students, to your questions and about how to get things like this built. So I'm going to share my screen. Please tell me if you're able to see everything. And as soon as you give me a thumbs up, I will start the slide show.
We can see it. So if you can, yeah, great, full screen.
Brilliant. So it's, I think, a term that we have been designing by is one of hedonistic sustainability. And this really is at the root of thinking about infrastructure in an entirely new way, in a way that you can, I think about how a power plant, this is a system that all of us, we all need to switch on the lights. We all need to receive heat or cooling in our homes at times. And how does the whole sort of systems of infrastructure work? We're looking for ways to allow for the creation of energy, not to be a single loop, but actually a loop that feeds continuously additional loops and repeated loops, so that the energy that you create actually has a longer lifespan. And as such, think about this as a power plant that produces heat out of the burning of household trash, but we're also using and the reheat, or the heat that's created, we're reusing and pumping back into the city, as well as actual electricity. And so the way of thinking about infrastructure that typically is the realm of engineers, we're trying to bring in a social layer where people interact with those energy systems and infrastructure systems, and that they then in themselves also have a larger sustainability kind of response that also is about hedonism. How can we create sustainability that actually creates a funner life, a more enjoyable life, a higher quality of life? We feel that with hedonistic sustainability, many more people would actually be coming and enjoying. So this is a diagram we put up where you can start to see how these energy loops start to feed one another. And as I've said, a power plant is, on the edges or inside all of our cities. This is a power plant on the edge of Copenhagen. It's been a waste to energy plant that's serviced Copenhagen for 60 years. It's kind of run its life, and therefore a tender was put out, an RFP process, to find a new power plant. Now, the difference between a typical power plant tender in another part, like in America versus one in Denmark, architects were invited to lead the process. And this is a really big decision, because there is an understanding that this waste to energy plant is in the center of the city. This is Copenhagen. 400,000 tons of waste go into this facility every year, and 550,000 citizens, so all of the citizens of inner Copenhagen, receive their heat and receive their electricity, and then 140,000 households receive their heat as well from this facility. And so it's the same as sort of a 3-kilogram household garbage bag is equal to 4 hours of electricity and 5 hours of heat. Or another way to look at it is 1 ton of trash is equal to same to 1 2/3 barrel of oil. Now, as I said, Copenhagen was sort of inviting architects to be a part of the solution and the design of this infrastructure, because typically, power plants like a waste energy plant are designed by engineers. And they're designed for purely utilitarian purposes, and they're usually fenced off. And I'm sure you've all heard of NIMBYism, not in my backyard. Who wants to have a power plant in their backyard? So I think the way that the Danes have gone about it, by including architects, by including urbanism as a part of the process of thinking about a power plant, they have gone from just boxes with kind of smokestacks to thinking about how this building fits into the rest of the city. Now, the building itself is going to be the tallest structure built in Denmark. It's also going to be one of the most expensive at around 500 million euro. So when you're building the most expensive and the tallest building in any city, you really need to start to think about and see it in relationship to all the other things. Now, what's interesting in the selection of placing the old plant 60 years ago, they placed it in actually an area where there's a lot of recreation. There's sailboats, a marina, there's a go-kart track, there's a ski kind of cable park where people go and celebrate the waterfront. So in the middle of all of this recreation where Danes and Copenhageners go to kind of, release some steam and enjoy the outdoors, there is this 60-year-old power plant right next to you. Now, Scandinavia, as you all know, is a Nordic climate, and there's a lot of snow in the winter. Now we're going to have mountains of trash. So the idea that we came up with during the design process of the competition, why not, since it's the tallest structure in Denmark, why not graft a ski slope on top of this plant? And, remembering that Denmark is actually one of the flattest countries in Europe, so there aren't a lot of hills. And if someone would like to actually go skiing in Denmark, they drive 8 hours to the north parts of Sweden and go skiing there, or to the Alps in the south. So by, again, this hedonistic idea of sustainability, providing the fun, providing the amenity right in the downtown heart of Copenhagen, you're reducing the carbon footprint of Danes going to other areas to have this wonderful ski amenity. So it's a huge power plant, and the architect is also asked to basically to skin it, or to kind of hide the guts of the building, which you see, right here. And by thinking about the facade and the envelope, that was a very big part of this project. So we needed to create a facade system that would be one of the tallest facade systems in, again, Denmark, or within a building that has been conceived in Denmark. And so you needed to actually create the structure so that these weren't just flimsy walls that were housing the guts of the power plant. Once you actually built the structure to allow for the skin or the envelope around the power plant, you actually didn't have to go very far to then build a roof. So the roof was almost a byproduct of the envelope. And then when we had this ginormous roof, we started thinking about what could be on it. And since there are all of these athletic kind of sporting kind of amenities around the project, why not bring those onto the site? And so we came up with a breakthrough concept of taking an elevator ride up to the roof and then being able to ski down, having a black diamond, having a sort of green trail and a blue trail, seeing how all of these things could sort of start to feed one another. And then we also extended the recreation into the surrounding areas. So the concept of how do you place a power plant into the center of the city? How do you make it aesthetically and urbanistically pleasing? How do you then have this wonderful facade that then requires the structure to stay up? Why not then layer on top of programming or use of that roof structure is how we came around to the design of Copenhagen. And, we then also started, of course, asking ourselves, well, does Denmark need a ski slope? And so we reached out to the public, and there is actually like a Danish Friends of Skiers or a ski federation. And we started asking them, what do you think of actually creating an artificial hill that would have artificial kind of snow in the summertime and then real snow in the wintertime? Is this something that you could see yourselves using? They were ecstatic. And so right away in the competition phase, we were already building up support from the general public to do this kind of work. This is a great BIM drawing right here that peels back the envelope. It peels back the surface. It shows you the guts of the structure. And you can see here that, this is what I meant by there's the guts of the building, and then you build up the facade, and then the facade needs to be reinforced. So you actually build the roof structure, and then it's just a matter of laying the ski slope material on top of that. This is the visual that we showed and won the competition against 5 other great schemes. But what the deciding factor was in our winning of this project was that the director of the Copenhagen looked at this project and said that for all of the NIMBYs that she has always confronted in her decades of being in charge of the power plant, she believed this was the first YIMBY power plant. Yes, I want this power plant in my backyard. For her, the ability to actually take budgets that she typically would have to hire lawyers to fight against all of the lawsuits of people wanting to close the power plant down, she could now see putting into actually the running and the kind of addition of the ski slope and maintaining it, and then having skis that people could rent. So imagine that. There's money that's spent annually on power plants to pay for lawyers to defend the power plants that could actually be spent in a much more productive, in a much more positive way. And so we won the project, and it then still took a good 6 years for that project to actually see the light of day, because it still had to go through a lot of regulatory approvals. It had to get the political support, it had to be budgeted, and all of these things. What we continuously tried to do was to build more and more people, public support. So we showed that it could also hold half-pipe competitions. We put in a mountain trail on top. We demonstrated that it could have a climbing wall, Europe's tallest climbing wall. And so we showed that it has got daytime skiers. It's got nighttime options for extending those hours. And this was then a video that was put forward once it was complete with that sort of special plastic mat. And I'll go a little bit more into detail about that. But that is really the 5th facade of this building, is that rooftop. and just trying to sort of see, it's the most ambitious kind of artificial skiing area in all of the world. So this is the manufacture of the ski mat, which is super exciting to, again, work with folks like this. So what exactly happens? Household waste is delivered from your houses every day through trucks into the waste bunker. There it is picked up by these massive forks that literally dump it into a furnace. The furnace heats everything up, burns it, and thus creates heat, which basically goes into a boiler and then runs the turbines that you see there in yellow, which generate the electricity. It then gets cleaned and cleansed through a filtration process so that the air that actually comes out at the top, the smokestack, is cleaner than literally the air that is out there naturally. So that was another major reason that this power plant allowed for people to be on top of it. The air quality actually had to be better than the air that people breathe. So we won this competition in 2009. We designed it. It then went through a series of mock-ups. Here is the facade mock-up. So these are aluminum kind of vitrines that basically build up like bricks the entire facade. And there we were also going to bring in landscape plantings, and we were going to sort of mock up a true tree line around the mountain where you could see the vegetation growing up to a certain point, and then you know, it would get less and less as you reach the tree line. But these were really important steps in proving the concept and showing how one actually starts to build this. And then there's the actual execution. This is, again, Denmark's largest construction site. You can start to see the marina on your left, the cable park, ski park on your right. There's also the go-karts further up to the bottom right. And literally also this new plant will take the place of all of the industrial landscape that you see there. So the one smokestack is taking the place of the other 4 smokestacks. And so that area too is now being redesigned and rebuilt. So this was a longer kind of 20-year effort to create really a new kind of energy source for the citizens of Copenhagen. And this is the project that will allow Copenhagen to become carbon neutral by 2025. I believe it'll be the largest urban area on the planet that is carbon neutral due to the investments that are being made into the infrastructure. So here you can see the facade of the closed facade, the weatherproof facade, and then on top of that, you place the aluminum sort of containers. Then think of this, like we actually, you know, ordered a ski kind of infrastructure from Doppelmayr in Austria, and they were like, what? You're where? In Denmark? Do you even have mountains? And so, you know, it's just this wonderful thing of being able to kind of manufacture. We brought in an amazing amount of landscape. We're really rewilding this gray area that was typically on the map and making it one of the most biodiverse areas in the city. And then within all of that, in the guts of the building, you have actually the power plant and how it's progressing. So it was a 4-year construction cycle just because of the sheer size and scale of the project. Here it's nearing completion, and here it is finished. So there are 200 people that also work there. So it's also an office space. It's a 200-person office building within a power plant. Wrapped by a ski slope and a climbing wall and a nature kind of preserve. So you move from the office where the administrators of the energy company are out into the kind of the guts of the building. Here you can see it starting to perform its function. It becomes really a postcard symbol of the city. Just like the Little Mermaid, people identify Copenhagen with the Little Mermaid, it's starting to also be identifiable with Copenhagen, and you start seeing people actually making special trips out there. I think it's a great destination for date night. Going up and walking up this artificial hill. There's a bar at the top, and you're able to get the best vistas around the city from there. The climbing wall was then completed as well. Another really wonderful facade element. You do need to have certain certifications. This is not an easy bouldering wall. It's got some undercuts, and I think one of the partners has been certified, and Jakob Lange has climbed the wall. But this is not for the faint of heart at all. So and it's just exciting. You start to see the mountain climbers who would typically race for the Matterhorn or for other mountains of the Alps, and they're making special trips to Copenhagen just to be able to sort of climb this urban legend in the making. So just in wrapping up, I just wanted to sort of talk about the fifth facade in that these are things that they existed on the marketplace, but they weren't enough. They didn't do everything we needed them to. So we even worked on the design of the actual mat. And one of the things you'll see is that they hadn't really designed in the expansion because it was such a large area, and when the sun hits it, it expands. And so you can see that we helped kind of slice in these space dividers within the mat. And it's also, we hooked and created a hooking system where you don't see the tile shape of the mat. It really looks like one continuous kind of flowing. And those are advancements that we help design within the mat. So it's also, you find something off the shelf, and then you have to sort of also design that into your project. It's not just simple sort of buy something and then install. You really have to start to think about how does that actually work? What are the new challenges because you're using it in a very unique way? And then how do you actually go about designing that? It's been thrilling to see the amount of birds and bees and, SLA, where the landscape architects, a fantastic group of folks. Here you see an up close picture of what that mat looks like, and then how that was like over time. And then it just has turned into an incredible verdant rooftop where everybody feels welcome, and all the people, and who doesn't want this as their power plant? That's the other version, a former version. And the way that Bjarke also talks about this is that he has a 4-year-old son, and for Darwin, this Copenhagen is now his definition of what a power plant should be. So he's looking forward in terms of what is the next iteration? What is the next power plant doing for my city? As opposed to the history of power plants and what they have sort of been in terms of just production machines and not necessarily sort of urban gifts to the city. So that is it in sort of all the kind of facets, and I'm happy to now hear from you guys. What are your hopes, dreams, and interests?
Thank you so much, Pau, for your in-depth presentation. It's really a thrill to be toured in such detail about the making of the project. And to hear your excitement and enthusiasm about it. It certainly is a groundbreaking project. I'll introduce Amy Goldfischer and Angie Syed again, who will conduct the interview. So I'll pass the screen towards Angie, and Amy is on Zoom as well.
Hi, my name is Amy Goldfischer. My partner is Angie Syed, and we'd like to thank you for your engaging and informative presentation. The story of the Copenhagen power plant's development from the competition stage to a commission to its eventual built outcome is one led by the vision and determination of its architect, Big. We understand the budget for this project was partly crowdfunded through Kickstarter. In your presentation, you pointed towards the power of the architect as an agency capable of instigating change. The architects in this instance had acted simultaneously as an environmental activist and venture capitalist. Can you share with us how and why this alternative mode of raising capital for an architectural project was used? Was there an insufficient budget provided, and was crowdfunded used to supplement the given budget? What parts of the project were crowdfunded, and what was added to the project brief as a result of crowdfunding?
Great question. And I will go back to kind of describe what was actually crowdfunded. And, you know, Kickstarter was also getting started while we were doing this project. And we were very intrigued by how to crowdfund ideas. And so I think if you think about the kind of any kind of project, you're going to continuously hit challenges. And you know, something that's more local here to New York is the Big U project, the resiliency project, and that's now in its 10th year. And to maintain a vision through different mayoral administrations and through different sort of funding mechanisms and through some federal funding, but then a lot of city funding. And you know, you have to be very creative on the funding side as well as on the design side. And I think it's keeping that in mind. So when we initially designed this project at the competition scale, you can probably see the smoke rings that are puffing out of the smokestack. And what we had envisioned and really wanted was to allow the power plant to communicate to the rest of the city. Every time a ton of carbon was saved by this new facility over the former facility, we wanted to celebrate that with a smoke ring. And we would puff out that smoke ring, and then people would be able to see with their own, you know, you could say use of waste or the lack of waste, how they could either affect the smoke rings puffing out more quickly or reducing them altogether. And that, you know, I think people only change their habits when they are informed. If you're not further informed, you're going to go back to your original habit. The only way that we're going to change people's attitude towards trash is to actually define what that means. The idea of this trash waste to energy plant is to actually, believe it or not, put it out of business. Because we need to actually start to think in a circular economy. And the circular economy means there is no waste. All waste is recycled and turned into something else. It goes back to that original graphic I started with, that you start creating energy and you loop it and loop it and loop it until you've really exhausted the energy source. So those smoke rings, well, we had to prove the concept. And that meant that we also had to really go into, you know, showing how it could be done. And the Kickstarter campaign was, I believe, $50,000, where we wanted to fund the prototype of the smoke ring generator and prove that the technical components could actually happen. And if you will bear with me, I know that we have a lot of questions, but I do have a video that I think would also help explain, you know, this part of the Kickstarter. So we managed to get the Kickstarter, which is incredible. So it was crowdfunded. People started getting really excited by what we presented, and you know, that then in turn also got people excited about what the possibilities were for the project as a whole. Sadly, though, we put in the mechanism in the smokestack, but there were also VE or cuts to the budget, which did not allow them to hook up the technical component in the smokestack to actually generate the smoke rings. So that would be something that would have to happen at a later date with more funding. So we managed to prove the technical aspect of it, but we didn't manage to get enough funding to actually implement it in the construction. Hope that kind of answered a lot of those questions.
Okay. So, hi, my name is Angie Saeed. I just want to say that was a really great presentation. Now, you did mention about NIMBYism. So our next question concerns the relationship between industry and the public and the infrastructure and the city. Intersecting public, social, and recreational infrastructure with clean energy infrastructure serves to rewrite the history of the relationship of dirty industry to the city and the legacy of the Industrial Revolution upon how cities are organized, which had generally zoned industrial areas and poor economic groups in the east, where the prevailing winds blow and are more polluted. The concept of intersecting energy infrastructure with public activities aimed to mitigate NIMBYism, the ism of not in my backyard, as you mentioned. Were there still people or groups who opposed the project, even with the benefits of the expanded public activities? If so, what were their reasons for their opposition? Lastly, after 4 years since completion, has the public embraced the Copenhagen Power Plant as a public, social, and recreational space?
So first of all, such an excellent question, because this is where I think things become quite political at times. And it's interesting that architects as a whole are not very political, right? We don't run for office. We don't really promote or state our political alliances very often. I find it's because architects are afraid that if they were political, they would alienate whoever's not, in their favor. And so as an architect, you try to be open, but at the same time, you're a little bit at the mercy of what the prevailing thought is. So to answer your question, there was a group that was still against the project. Their whole idea was that the transformation of a waste society to a non-waste society was not happening fast enough. And so they wanted to go cold turkey circular. And we were saying that it's really hard to imagine a world that will be circular tomorrow, and that we need to create transitional actual infrastructure that takes you from a place to another place. And so that's a question for you and your generation of designers is, how do we move the needle quickly enough to address climate change and climate catastrophe, right? And how do we get there? So a project like this looks good on paper, it looks great in practice, but is it fast enough? And that's what the people who are opposing it were saying, is that we're spending so much money to be yet another 30 or 40 years trapped in the waste creation bubble. But what we're saying is, let's put this plant out of business, because, and it's not about like being wasteful about the plant. The plant could turn into a recycling plant, right? So you could suddenly go from burning waste as your best use of energy and efficient use of transition to let's recycle 80 or 90% of our waste. Our waste currently is not 80, 90% recyclable, right? So we don't yet create the products that one could just turn into something else. That's the first thing that has to happen, is that our design of the world, of the products, of the food, of the containers, of the packaging, we all need to work towards creating a circular kind of economy. But just to answer your question, so now within the 4 years, people love this plant. It actually has usage problems because people are using it much more than it was intended. So the wear and tear and the maintenance costs are higher, but that's actually a good thing. So it's very exciting to see how the Copenhageners embraced it. It has literally made people travel to Copenhagen just to see it. Greta Thunberg was on the roof of it. Mayor Bloomberg, Michael Bloomberg was on the roof of it. You know, people are coming to Copenhagen to experience it. And I think it will have that positive change to other energy plants around the world. But we have a bigger question and responsibility, which is how do we change our habits to becoming a no waste society?
Right. So in the Copenhagen project, BIG's ambition to create world-changing architecture applied the agency of a programmatic strategy to create strange post-natural combinations, not wholly different from Bernard Tschumy's cross-programming or OMA's paranoid serialistic method. So within this disciplinary context, can you elaborate on the programmatic strategy of mixing energy infrastructure and public recreational activities, which create a synthesis of unexpected combinations and even surrealistic effects?
I would go a little bit less academic and just more of the people by saying that, you know, the BQE that we're working on right now here in New York was conceived in the 1950s and was built in that period of time and into the 60s, and really was just getting people from point A to point B, again, designed by traffic engineers, Robert Moses, and just creating a lot of infrastructure. It did a lot of other things. It forgot neighborhoods. It forgot and, cut a lot of things from each other. It had profound economic byproducts, which I think, at the human level, we should not be designing infrastructure without thinking people first, or even go so far as organisms first, species first, because here we've demonstrated that the birds and the bees have as much right to this area as humans, has as much right to the area as the workers. We need to create, it's complex, but that's also what we have to address. We can't make the world easier by mono zoning, single zoning a bunch of areas and say, this is where you work, this is where you live, this is where we create energy. That doesn't work. We need to create more complexity. We need to design that complexity as a positive part of life. And then we need to coexist. And I think we have much greater respect. I would assume someone would have a much greater respect for this energy plant. And, school children are going to take tours of this thing, and they're going to have a much better understanding of their connectivity to this power plant than any other power plant. And, where school buses are probably not welcome. That's how I see it on a kind of more social level. I think social infrastructure is what we have to talk about.
Right. So ultimately, does the architecture of a city's public institution, infrastructure, and technical apparatus have the obligation to educate? Can you comment on the expanded role of architecture to inform the public and to ultimately educate its users? More broadly, what is the power of architecture to educate and how specifically does the Copenhagen power plant educate the public on green energy?
Yeah, I think it's a continual process of education. So there is actually a room dedicated to education for those school trips, for those dignitaries that come in from out of town, for energy municipalities and authorities. They go to this plant and there's a room dedicated to the learnings. They take tours, things are accessible. So there's a continual learning, and I don't think that there's a frozen moment in time that we have dictated. I think we've created a framework for as much of this to happen. And it's really up to now the people who run this facility and for the programmers. But they now have a whole new way of interacting with the citizens. So they can have also events that bring different types of citizens to the plant, and then while they're there, they can educate through screens or through handouts, or again through tours and personal experience. But I do think that the education component was very much high on our agenda and on our thinking of how this facility, and that's also why the director stated she chose us, was that there were a lot of byproduct wins in choosing this scheme over another scheme. And but I think it's the architect themselves is not there to create the curricula or the educational kind of program. That is actually something that I think all of us contribute to, but is driven by the people who run the plan.
Thank you.
The climate crisis has led to radical approaches to greening industry and infrastructure and the relationship between architecture and its environmental impact. Processing residual household waste, this project simultaneously creates a biodiverse landscape with capacities to absorb heat, remove air particulates, and manage stormwater runoff. What is left over after waste? BIG has published the Copenhagen Power Plant project, arguing for what you call hedonistic sustainability as the concept behind the design of this building, as well as many other big buildings. Further to your presentation, can you please explain the concept of hedonistic sustainability? Does this notion imply the public enjoyment of clean infrastructure and the environmental, social, and urban sustainability of this building to enable new experiences for the public to come closer to industry?
So I'm sure, Amy, you probably wrote the question before the presentation. So I do hope that I have defined what we see as hedonistic sustainability. It's, you know, sustainability through decades now has been the act of more of a Puritan approach of reducing. So it means not taking, you know, hot showers, but cold showers. It means not flying, but maybe walking or boating or, you know, taking the train. It means smaller windows because you need more insulation. And that's something where you're going to have a group of people that would reduce their life enjoyment or life quality, or, you know, you'll have a group of people, but it's not going to be all people. The way to get people to change their habits is to demonstrate that there's a higher quality of life with this approach and with this kind of idea about resource allocation. And if people see that they can have bigger windows, if they can take hot showers, if they can take you know, flights, they will very likely move towards that lifestyle than the other one. And that is just in terms of thinking about mass adoption. Now, someone would say, yeah, but how could you take hot showers because you'll need electricity? Well, we have ample amounts of electricity and it's called the sun. So if we've got this sun that just does not, you know, it's there, and we just need to now harness and build a world where we take the energy of the sun and then are able to also pump it wherever we need it at a given time, even at night when the sun isn't there, or wind, same way. Sometimes it's windy, sometimes it's not. How can we actually balance out need and production? We feel that with a global energy grid, we could actually produce way more energy than the 10 billion people that are kind of projected to be living on the planet by 2050 would ever need. So it's not a matter of designing less energy, it's designing systems that produce more energy than we need in a renewable fashion that doesn't, you know, require more energy to be spent to harness the energy. And then we just need to be more intelligent about how we use it. So it's really about thinking of the bigger picture and creating a more enjoyable, a more higher quality of life. And then we can move very quickly to that adoption. That is hedonistic sustainability.
Awesome. So as you mentioned earlier in your presentation, that the Copenhagen power plant is capable of converting 440,000 tons of waste into clean energy annually. Copenhagen delivers electricity and district heating to 140,000 homes. Applying advanced technology in waste treatment and energy production, Copenhagen is claimed to be the cleanest waste to energy power plant in the world. Now, our question is, can this building be understood as a prototype for other hybrid infrastructural buildings in Denmark or anywhere else in the world? Is this kind of a radical project possible to achieve in developing countries where budget is not as, it's limited? And were there any precedents you had considered as examples of strange intersections of recreational infrastructure mixed with clean energy infrastructure?
So yes, in so many ways it is a prototype, and we are actually in active conversations on a couple of energy projects elsewhere. I actually do feel that even in emerging economies, this is actually a very viable concept because oftentimes energy grids are at the very source of global funding initiatives like the World Bank or ESG funding, there are many different funding mechanisms to create transition type of kind of events like this. So I honestly feel that on a smaller scale, medium scale, large scale, this is very implementable. And the funny thing is that the waste to energy was presented in the 1970s to America as a possible energy source because energy prices went really high, and Tom might remember this. And the fossil fuel companies were trying to basically run it out of business and created a marketing campaign that said that waste to energy plants, which typically are in centers of cities as opposed to in the boondocks or in the farmlands, and as such, they presented smelly, nasty kind of energy plants within urban centers, and they defeated the purpose. Whereas Denmark truly adopted the waste to energy kind of concept because they had no place for the trash to go. And so, believe it or not, America puts everything, all waste, into landfills. All of those landfills are actually energy source. Maybe one day it will be, cost effective to go to a landfill and actually make that into an energy plant because you have unlimited sources of waste. So just think of how ironic it is that, and we were called in the most, when this came out, I remember a call from the Pentagon, and it was someone that was, they were in Iraq, and they were fighting in the desert to protect oil, right? To protect fossil fuel. And the general that called, or whoever, whatever level he was, maybe a quartermaster, was basically saying, sir, you're telling me that the waste that we produce in this camp is actually fuel? And I said, yes, sir. He goes, well, we actually put our waste onto semi-trucks. We drive it through the desert and get shot at so that we can dig it under a bunch of sand. And they were literally, they had an energy source within the camp that they then were actually taking out of the camp because they didn't want to smell it. And they, in order to defend the fossil fuel energy. So none of these things really make sense. If we have the knowledge, every municipality in the United States could be burning its household waste and having incinerators and having these technologies. So this is a real thing. It's a proven technology. It's being used very effectively in Scandinavia and in other parts of Europe. Could also happen here.
Right. So in addition to my question, do you think that the concept of Copenhagen can be replicated to transform other existing power plants that also burn waste and convert to energy? In other words, do you believe other older power plants can be retrofitted to be clean and be compounded with public, social, and recreational activities?
It's always going to be a big question of retrofitting and the cost thereof versus building a new. They had that exact same question in Denmark with the old plant, and they decided to build the new plant adjacent to the old plant because it was more costly to retrofit, and just because so much has changed. And you'll see that, you know, the square footage of this plant is like 1/5 of the former plant, but they produce the same amount of energy. So even a retrofitting of an old plant that's old or outdated technology doesn't mean a one-for-one transition. Things just change, and therefore other factors might come into play when deciding that.
Thank you.
Hey, Amy, I found the slideshow of the Kickstarter campaign. Do you want me to show it to you?
Sure.
All right, so this is, I'm going to stop sharing and then I'm going to reshare. And then you tell me if, again, you guys see everything. You do, right?
Yes.
So, you know, I told you about the smoke rings, and that, you know, we were trying to basically get this to be how one would communicate what is happening in the plant. So we actually went as far as actually designing the whole mechanism. This is, of course, in Danish, so I'm sorry about that. But, you know, we looked at, you know, you have 3 sources of let's say you have smoke, you have the products of burning, or sort of the more, it's still smoke, but it's got more substances within it. And then you have steam, or the hot air that's also being produced. So we realized that, you know, within the smoke ring, there would be a lot of other gases. So we very quickly moved over to a steam ring to be that communicative tool. And then with steam, you have to then think about how to maintain, it's harder to maintain the ring. So if you've got those other gases, it's easier to maintain the ring. But we wanted to basically create basically like I think it's a 10-foot wide ring of steam. So we looked at kind of like how it's typically done, forcing air into a chute. We looked at, you know, splitting that. We looked at sort of widening that split in order to create the width that we needed. And then how or where the mechanism would have to be actually implemented within the smokestack to create that. And this is the mechanism that was designed, basically a steam ring generator. We used some folks that were really into rockets and rocket propulsion. So we started to basically design this mechanism that could then fit into the smokestack to basically create, this is the 4th test, which was.
Oh, I see it. Nice.
So he's very happy. That was Jakob. And we demonstrated that we had the technology, we had the capacity to basically create those smoke rings. And that here you can see where it's actually worked in. This is actually built in. It's just not turned on, believe it or not. So we put it out there, and then we demonstrated how much it would cost and so forth. So that was the Kickstarter campaign.
That was great. Thank you. Shifting our discussion towards facade technologies, a set of differentiated modules and patterns of the ALU bricks wraps around the facade of the building as a checkerboard of solid and glazed panels. How and why did BIG create a set of 3 distinct module patterns inset into the regular grid of modules? And what is the reasoning and possible performance of these design decisions?
You probably noticed in the, remember I told you that like a portion of the building is an office building. And the office building comes with certain code requirements in terms of amount of daylight into the office space. Some of those also have to be operable for fresh air. And so we looked at all of the different programmatic elements. So there's an office building, there's the guts of the actual plant. There's an elevator that takes you up to the top. There's a bar at the top of the roof, which also wants to be able to look out and use it as an observatory kind of place. And so we quickly did come to kind of a module that allowed for the right amount of daylight in. It allowed for those vitrines to be placed so that we could actually fill that with landscape and start growing vines or growing things on the facade. And then we needed to create apertures or openings for trucks to drive through and for the skiers to come down and hit the ground. So it's a brick pattern that allows for a lot of flexibility. It took the corner by sort of faceting the corner. And it was just a very, I think, workable, flexible kind of facade solution that allowed us to do everything that it needed to.
Great. So our next question concerns the relationship of Copenhagen Power Plant project to BIG's larger portfolio of work. So further to your presentation, can you share us the genealogy of the design of the Copenhagen project within BIG's portfolio and BIG's portfolio of preceding projects? Are there projects which led to Copenhagen as earlier prototypes which you have developed further?
A great question. We have in the, if you know our books, Yes is More, Hot to Cold, and Form Giving. In the back of Yes is More, which came out in 2009, the year that we won Copenhagen, there's a really interesting kind of family tree that looks at all of our projects and how they're related. I think it's, if I'm right, it's called like pragmatic utopia or something, and it's evolution, pragmatic evolution. It looks at how our projects do inform or are built upon the ideas of multiple projects, that everything is a bit of an evolutionary kind of process. I would not specifically say that there is any one project that would be a precursor to Copenhagen. Certainly there are aspects like, you know, the mountain is a project that predates the Copenhagen, and it too has a fifth facade, which is, you know, this beautiful landscaped kind of roof structure. It's residential, therefore all of the roof landscapes are individual gardens for the units. But it's just this idea that, you know, that the roof is actually something that should be enjoyed, and the roof is something that should be verdant, and that, you know, birds should be attracted to your buildings. That idea, I think, is definitely in a series of projects, and then became even more embedded in the Copenhagen project.
Thank you. Please share with us how Copenhagen has influenced your practice's recent and current work. In more broad terms, what has been the impact of the Copenhagen project on your practice and more recent portfolio of projects?
So as a piece of social infrastructure, I would say that any piece of infrastructure that we work on now, be it a power plant or a bridge or a highway or flood management systems, it's really to realize that the world is a very big place. There are many pieces of infrastructure that are continuously and daily designed around us. And we as architects should be a part of their design and their thinking. Every time you come up against a really dumb gray wall that cuts you from whatever other pieces of life there are on the other side, someone has made a decision to place a piece of infrastructure, a flood wall, that might not be the smartest use of concrete or of urbanism. So that's where we have to also be a part of that process. And, you know, we believe that Copenhagen has given us the confidence. It's given us a little bit of, a kind of proof that that we can take something on the scale of the city and contribute. So that makes it a little bit easier each and every time we propose those kinds of large scale ideas. But it's never easy. When you work at the scale of infrastructure, you are literally opening up yourself to, again, not just years, but perhaps decades of effort, and not just individual clients, but really a room full of hundreds, if not thousands of people who have an opinion about what you're doing. So it requires also very unique skills that I hope you're learning at NYIT.
So this Beyond the Envelope series of presentations and interviews is set within a Master of Architecture course here at NYIT and within our SOAD public series of lectures and events. And therefore your audience is predominantly students as well as future architects. So in this context, can you please share with us, from your viewpoint, any advice you may have for the next generation of architects?
Think big.
That's good. No, but thank you very much for your fantastic presentation, and we are like so honored for having this opportunity of having interview today.
Thank you.
Yeah, thank you very much, Kaiwa. Your enthusiasm, expertise, generosity today is really greatly appreciated. Thank you so much.
You bet, everybody, and hope to see you around. And I'm sure I'm seeing some of your classmates here in the office. See you.
Very much. All the best. Take care.
Thank you.